real and imaginary part. Remember our set of complex numbers, right? We had a real part. Let's just go back and look at the set we talked about earlier. Okay, our complex numbers. I have a real part over here, okay, and I have an imaginary part over here. Right? So we are going to look at what it looks like. Any number that is in the real system or in the real set can also be expressed as a complex number, like the number 2. Now remember, the number 2 is also a whole number. It's also a natural number. Remember, it percolates up. The number 2 can be written as a complex number because it has 0 imaginary part. Yeah, 0i. And so this is a real part. Okay, that's my real part. And this is my imaginary part. And I can also take an imaginary number, say 3i, and write it as a complex number because 3i by itself has no real part. Or I can take a number that has both a complex and a real part, say 5 minus 4i. They all look like binomials. And if we sort of trick our mind into thinking that I acts like x, we can do a lot of really cool stuff. In fact, we could see whether or not complex numbers follow the rules for polynomials. Now remember, if I had 2 plus 3x, and I was going to add it to 4 plus 5x, I would collect like terms. I would take 3x and add it to 5x. So that's 3 plus 5, that's 8x. And I would have 8x. That would be these two here coming together. And then I would take my constants and I would add them together, which would give me 6, because 2 plus 4 is 6. And I would have gotten the binomial answer. Guess what? Our imaginary numbers work exactly the same way. 2 plus 3i plus 4 plus 5i. I'm going to do the same thing. Okay, 2 plus 4, 2 plus 4 is 6. And 3i plus 5i is 8i. And I've just added 2 complex numbers. The same rules for saying subtraction, they work exactly the same way too. Let's say I have 8 plus 6i, and I'm going to subtract 2 minus, I don't know, 9i. Alright, this is a subtraction problem. Remember, we have to use the distributive property. If this had been a problem with x's, I would have to distribute the negative sign inside the second polynomial. So I would have 8 plus 6i minus 2 plus 9i. Collect like terms. Okay, that was 6 plus 9, that's 15i. And 8 minus 2 is 6. And there's my answer, 6 plus 15i. See, that follows the exact same rules. Alright, now, what about multiplication? Does it work for multiplication too? Well, let's find out. If I was going to multiply two binomials, say 3 plus 2x times 1 minus, I don't know, 4x. Okay. Me, I like to use the box method. It's a little bit faster, quicker, and a little bit more visual for me, and I'm a visual person. So I'm going to say 3 and 2x and 1 and negative 4x, and I'm going to fill in my box. 1 times 3 is 3, 1 times 2x is 2x, 3 times negative 4 is negative 12x, and 2 times negative 4 is negative 8x squared. And I'd get 11, I'd collect like terms, and then end up with, let's see, 3 minus 10x and minus 8x squared. So let's see if this works if I change all those x's to i's. So if what I had was 3 plus 2i times 1 minus 4i, draw my box out. Right, I have 3 and 2i and 1 and minus 4i. Okay, so now I'm going to say 3. Okay, I still get 3 here. I still get 2i here. Remember, this is i's, not x's. Negative 12i and negative 8i squared. Okay, now we'll collect like terms. All right, so I get 3 minus 10i minus 8i squared. And this is where it becomes a little bit different, because guess what I squared means? I squared is actually a real number. I squared is negative 1. So what I really have is 3 minus 10i minus 8 times negative 1. What is 8 times negative 1? 8 times negative 1 is positive 8. Well, I can still collect some like terms here. What's 8 plus 3? That's 11. So my actual answer is going to be 11 minus 10i. And there's my answer. Right? The only difference in multiplication was when I got that squared I. That's really nice, because squared i's are i's to the 4th power, or i's to the 6th power, or i's to the 8th power. Hopefully by now you've learned that all even powers of I are real. They're either 1 or negative 1. Any questions? Practice these problems. I know y'all can do it, and take care.